Okay, in a certain AP, 5 times the fifth term is equal to 8 times the eighth term, then A13 is what? So this equation, we know that A8 can be written as A5 plus 3D and A13 can be written as A5 plus, so 13 minus 5, that is 8, I think, right? Yeah, of course. Yes, okay, now what? Now just put that into this, so it's going to be 5 times A5 equal to 8 times A8, but A8 is this thing, so yeah, it's just 8A5 plus 24D. Cool. So from that you have 3A5 equal to negative 24D. Negative what? Negative 8D. Alright. So you can figure out what A8 and A13 must be. Well, yeah. Then its 13th term is this is kind of complicated. So you know what D is in terms of that? Yes. Hey, this doesn't, okay, whatever, just think about A13. A13 is A5 plus 8D. Oh, that is 0. Next, if 7th and 13th term of an AP are 34 and 64 respectively, then its 18th term is, okay, 7 and 13th term is given 34 and 64 respectively. So our difference, that will just be 64 minus 34 upon, so the number of jumps, which will be 6. So this is just 30 upon 6, which is 5, right? And we want the 18th term, which is A13 plus 5D. 13th term is 64 plus 5 times the difference. Difference is what? 5, so it's plus 25, which is 89, I think. Next, the 7th term of an AP is this thing, then the sum of the first 13 terms. Sum of the first 13 terms, that's going to be 13 upon 2 into 2a plus n minus 1. In this case, 13 minus 1 is 12. So 12D, right? That's what you want. And the 7th term is, actually you can write this as 13 into a plus 6D. And the 7th term is also a plus 6D. So this thing is just 40. So 13 times 40, which is 4 and 12 is like 52, I think. 520. Next, the first term of an AP is 2 and common difference is 4. The sum of its 40 terms will be, so first term is 2, common difference is 4. What kind of question is this? This is stupid. Okay, 4, sum of the first 40 terms, so 2a minus d plus n, which is 40 times d. This cancels. Yes, so this is just yeah, like it's 40 squared into 2, so it's 1600 into 2, 3200. There you go. Next, sum of the first and third term of an AP is 12, which means the second term is 6. So 6a minus d. Okay, why am I writing this? Okay, the second term is 6. That's all they are saying. And the product of the first and second term is 24. So the first term must be 4 in that case. The first term is, it's 4, of course. Next, if the sum of the first 2 n terms of this is equal to the sum of the first n terms of this, then n is equal to, so 2n terms of this thing, that's going to be 2n upon 2 into a, which is, well, actually 2a, so 4, then minus d. D is 3 in this case, okay, plus d times n, so like 2n in this case, so 2n times 3 is 6n. Okay, so this quantity is equal to the sum of the first n terms of that thing. Okay, so n upon 2 into 2a minus d, in this case d is 2, plus n times 2, and that's going to be n into 57 minus 1 plus n, which is n into 56 plus n, and this is equal to what? N into 1 plus 6n. So either n is 0, which doesn't make sense, or you have 5n equal to 55, which means n equal to 11. N is 11 hopefully. Next, if the sum of 10 terms of an AP is 4 times the sum of its 5 terms, sum of the 10 terms of an AP, okay, is 4 times the sum of its 5 terms, then the ratio of the first term and common difference, right, no big deal. So it's just 10 upon 2 into 2a minus d plus nd is like 10d. Actually, no, just write as 9d. Who knows? That might be the best thing. This thing upon the sum of the first 5 terms. So it's going to be 4, I think. This ratio is 4. Yes. This is going to be 2 over there. Cool. But that 2 cancels with this thing, so it should be a plus 2d. So it's 2a plus 9d equal to 4a plus 8d. So 2a equal to d. Ratio of the first term and the common difference. So a upon d. That thing is just 1 by 2. Yes. 1 is to 2. Okay. If the sum of the first p terms, first q terms and r terms be x, y, z respectively, then this thing x upon p into q minus r. Okay. Fine. So sum of the first n terms, that's just n upon 2 into 2a minus d plus n times d, right? Okay, which we can write as a minus d by 2 into n plus n square d by 2. Okay. Right. Now we know what kind of polynomial we are dealing with. So these terms are like x, y, z. Then x upon p. Okay. So this is s of n, of course. So s as a function of n upon n, that thing, that's just a minus d upon 2 plus n squared, sorry, okay, just n into d upon 2. Okay, cool. And then what? X upon p, and then that times q minus r for some reason. Why is this multiplied by q minus r? So like, what is s sub p minus s sub q? Right, that would be okay, this is going to be bad. This is going to be really bad. That will be basically p minus q into a minus d upon 2 plus p minus q square into d upon 2. That times this. Oh, this is getting bad. I wish there was some easier way to do this. Q minus r. Like, okay. Oh, wait. No, we don't want s. We just want q minus r. That's it. That's all. Like, q and r are values of n, not values of s. Yes. X, y, z are values of s. Okay, so just gotta put this n as p and get that value. So this will be a minus d upon 2 into q minus r, right? The sum of this thing basically. And the other term, that will be summation of, what was this, p times d upon 2 into q minus r. But p times q minus r, that's like pq minus pr. And of course d upon 2. So this thing cancels. I mean, this telescopes to 0 and this also telescopes to 0. So yeah. Oops, what? Why did this happen? Okay. So this is just 0. Yeah. Looks right. I believe it should be 0. X, Y, 8x, y, z upon p, q, r. Why? I don't get it. Like, for example, if p, q, r, if these were all equal, then you could have x, y, z being non-zero, p, q, r being non-zero, but this still turns out to be 0, and this doesn't turn out to be 0. So this is definitely not correct. Neither is this correct. Okay, next. Sum of all odd numbers of 2 digits. All odd numbers of 2 digits. So 2-digit odd numbers start from 11. So 11 plus 13 all the way till what? 99, right? So there's like difference of 2. Well, what's n? We don't know what n is. Oh, come on, think about it. What is n? The difference is 2, so 88 upon 2, that's 44. But then this thing plus 1, which is 45, so there's like 45 terms. It looks like that. Is this 45 terms? It looks like that though. Think about it, the total terms, if we start from 10 to 100, it's like 90 of numbers, and then you take half of that 45, because even and odd are like in equal amounts. 10 is followed by 11, similarly. Yeah, like, no, okay, we start from 10 and we go to no, we start from 11 and we go till 100. That's more like it. So you should start from 11 instead, because the first 10 numbers are 1 to 10. So the 90 numbers that we're talking about are 11 to 100, and then half of that are all the odd numbers in there, because odd number, even number, that it's in that pattern. Cool. So yeah, there's just 45 of them. So 45 upon 2 into addition of these two is like 110. Yeah, and that's going to be 45 into 55, I think. Which is, so 45 into 5, that will be 225, I think, and that into 11, so 225 and 5742, so 2475. Cool. Next question. The sum of n terms of the series, this series is, oh, I think I know how to do this thing. So it's like 1 upon square root of n plus 2 plus square root of n. That's what this is, right? We can write this as, okay, multiplies by square root n plus 2 minus square root n on denominator and numerator, and this will give us 2 in the denominator, I think, and square root n plus 2 minus square root n. So this is a telescoping series, of course. So yeah, it's going to be half of square root 3 minus 1 plus square root 5 minus square root 3 all the way till n terms. So 1 is 2n minus, 2 into 1 minus 1. This is 3 is 2 into 2 minus 1, and so on. So for the nth term, this will be square root of the smaller number, that is the smaller number will be 2n minus 1, I think, and the bigger number will be 2n plus 1. Now let's see, this cancels, it keeps on cancelling. Just have this. Okay, yeah, looks correct. That's what this is, I think. Next, if a1 a2 all the way till an plus 1 are in AP, then this thing is, oh, so all of these are in AP, huh? Well, then multiply by yeah, so like 1 upon d into d upon a1 a2 and all that stuff. But then you can write d as a2 minus a1, so it's essentially just 1 upon d into 1 upon a1 minus 1 upon a2 plus 1 upon a2 minus 1 upon a3, and so on, till you eventually have 1 upon an minus 1 upon an plus 1, right? And then lot of cancellation, and you have 1 upon d into 1 upon a1 minus 1 upon an plus 1. Yes, so this will be 1 upon d into an plus 1, oops, minus a1 upon a1 an plus 1. Yeah, and what is an plus 1 minus a1? That's n times the difference. So this is equal to n upon a1 an plus 1, I think. Yeah, is it there? This looks correct. Next, after inserting n AMs between 2 and 38, the sum of the resulting progression is 200. The value of n is, so you know what the first and last term is. This isn't like a big deal at all. So it's just 2 plus 38 equal to 200. The number of terms in the progression, you can just find that out. So n into 1 plus what, like, okay, this is 40, so it's just 20 over there, equal to 200. So this is 10. There were 10 terms, that means you put 8 AMs in it, right? Okay, n AMs, that means n should be 8. This n is different in that case. It's the total number of terms in the progression. 3 AMs between 3 and 19 are okay, fine. What's the difference? 19 minus 3 16, I think, upon 4. 3 plus 1, because there's 4 jumps, right? That would be 4. So it's 3 7 11 15 and then 19. So these are the 3 AMs: 7 11 15. Cool. Next question: if these are AMs between 2 and 12, then the sum is equal to, okay, how many of them are there? 1 2 3 4 5 6. So there are 6 AMs between them. That means total there are like 8 terms in the progression. So 8 upon 2 into 2 plus 12, that will be the sum of the progression, that minus the first and last term, that will be the sum of all the remaining terms, which is exactly what you want. And that's going to be equal to 8. But 8 by 2 is just 4. So 4 into 14, or you could say 8 into 7, whatever, which is basically 56 minus 14, which is 42, I think. Yeah, there you go. Next question: if these are in arithmetic progression and these are adding up to 225, wait, a1 a5 a10, okay, this is different. It's not a sum, it's something else. Well, a1 plus a24, I think I've seen that somewhere, right? What's their mean? No, maybe that's not the way. Okay, a24, that is a problematic thing. Yeah, I mean, like, 25 upon 2, that doesn't exist. I mean, that's not even that progression. So okay, then a1 plus a2 plus a3, so on till 24, of course. What is that equal to? I mean, I understand that a5 plus a20, that turns out to be 2 times of a15. Sorry, no, that turns out to be the same as a10 plus a15. Oh, okay, now I understand what's happening. In fact, it isn't that bad. So a10 plus a15, that is the same thing as a1 plus a24, because 10 plus 15 is 25, and this is also 25. So yeah, the coefficient of d adds up. The coefficient of a is 2 in both of these values. Similarly, you have a5 plus a20, because these add up to 25. So yeah, you can just write this thing as 3 times of a1 plus a24. That's 225. So a1 plus a24, that thing is 75, I think. Yes. So this sum, this will just be 75 into the number of terms, which is 24, I think, upon 2. So it's 75 into 12. Yes, which is, so 75 into 4 is 300, and that into, once again, just 3, so 900. ABC are in AP, then this thing will be in also in AP, I think, because just look at this. This thing is just A upon ABC, and B upon ABC, and C upon ABC. ABC are in AP. These things are also in AP, with the difference being B upon ABC, right? Next, if log of 2 power n minus 1 and log of, okay, these are in AP, then n is, that means 2 log of 2 power n minus 1, that's equal to log 2 plus log of 2 power n plus 3, which we can write as log of 2 times of 2 power n plus 3, and similarly this can be written as log of 2 power n minus 1 squared. So clearly these two things must be equal. So squaring this, just get 2 power 2n minus 2 into 2 power n, which is basically 2 power n plus 1 equal to 2 power n plus 1 plus 6, I think. Cool. Which is 2 power 2n minus yeah, like 2 into 2 power n plus 1, which is like 2 power n plus 2. That goes over there, it becomes negative 5 equal to 0. But in fact I'm going to say 2 power n is like x. So this will be x squared minus 4x, because this 2 goes on the front, it becomes 4, minus 5 equal to 0. So it's x minus 5 into x plus 1, I believe, right? Minus 5 into 1 is minus 5, and this is minus 4. So x is 5, because of course this is just positive, you cannot have negative. So wait, what? But then it's 2 power n. How does that make sense? So log base 2 of 5, that thing is what n is. But how does this make sense? This should be an integer, but oh, maybe like n is not an integer necessarily. Then it's correct, log base 2 of 5. This was very weird. Yeah. Okay, the numbers, okay, these numbers will be in classic. It's very classic, it's just in GP, because square root 2 plus 1 and square root 2 minus 1 add up, multiply to 1, right? So these are reciprocals, and this is 1. These are of course in GP, because b squared equal to AC. Next, if the p, q and rth term of a GP are a, b, c respectively, then this thing is equal to, okay, rth term of a GP. Okay, cool. So let's just say, like, I don't know, a is a r to the power of p, where this a is like the first term upon the ratio, or I don't know, like call it the 0th term if you will. And similarly b is a r power q, and c is a r power r. Wait, what? Oh, let's just use capital R in that case. Right, and using this substitution we can get some stuff done. Yes. So this will be like a to the power of q minus r plus r minus p plus p minus q times r to the power of, so times r to the power of, let's see, p into q minus r plus q into r minus p plus r into p minus q. As you can see, this, all of these turn out to be 0, so it's just 1. If the third term of GP is 4, then the product of its fifth, okay, of its first 5 terms is, so the third term is 4, the fourth term will be 4r, the second term will be 4 upon r, the fifth term will be 4r squared, the first term will be 4 upon r squared. Multiply these out, you just get 4 power 5. Cool. X 2x plus 2, 3x plus 3 are in GP, then the fourth term is, these are in GP. Okay, so clearly the ratio is just 3 upon 2 from the ratio of these two, but at the same time it's also equal to 2x plus 2 upon x, right? That means 3x is 4x plus 4, x equal to negative 4. There you go. X equal to negative 4, that times 3 upon 2, that's going to be negative 6, and then negative 9. Then the fourth term is negative 27 upon 2, which I think, oh, they are putting it in decimals, which is like negative 13.5, okay, yes, negative 13.5. The first term of an infinite geometric progression is x and its sum is 5. Okay, its sum is 5 of the infinite geometry, right? So a upon 1 minus r equal to 5. Then instead of saying a, I should just say x. So 5, okay, no, x upon 5, that is 1 minus r. R is 1 minus x upon 5 in that case, right? Yeah, but we know that r must be between 1 and 0, or in fact between 1 and minus 1. That's better for that to happen. So you have 1 minus x upon 5 being in between 1 and minus 1. Multiply this thing by negative, so 1 is bigger than x upon 5, minus 1 is bigger than minus 1. Add 1 on each term, so it's going to be 2 bigger than x upon 5 bigger than 0. Multiply by 5, so 10 bigger than x bigger than 0. There you go. Okay, next, the two geometric mean between the term 1 and 64 are the geometric mean between the numbers 1 and 64. What was I doing? Yeah, of course. So I don't know what was I doing. So two geometric means, right? You just have r to the power of 3 equal to 64. Okay, r is 4 in that case, so it's just 1 4 16 64. There you go. So it's 4 and 16. Next, the gm of the numbers 3 3 squared 3 cube, so on. So how many of these? N of these is just the nth root of like 3 into 3 squared into 3 cube all the way till 3 power n, which is nth. Okay, just like 3 to the power of 1 plus 2 plus 3 all the way to n, we know that's just n into n plus 1 upon 2, but all of that to the power of 1 upon n, so this cancels, so 3 power n plus 1 upon 2. If ABC are in AP, this thing are in GP, then A is to B is to C is ABC in AP and B minus A, C minus B and A are in GP. Well, that means C minus B squared. Oops. C minus B squared is equal to, well, B minus A, that thing is just the difference, right? And C minus B, that is also just the difference. But how can that make sense? Oh no. Oh no. Look at that. It's always A's to B's to C's, like in an increasing order. What that means is, yeah, like this is in fact just one difference and this is just one difference. That means A should also be just one difference. Yeah, or you will break the momentum, which we don't want. So A is the difference. Oh no. So it's difference, 2 difference, 3 difference. So it's 1 is to 2 is to 3. Okay, next. If ABC are in HP, then the value of this thing is, right? Wow, what is this? Why is this? So the first guy doesn't have A, this guy doesn't has, it has no B, and this doesn't have C. So you want to write it in each of these formats. So first thing, you want to exclude A. Yeah, how would you exclude A? You just have this one identity, that 2 upon B. You know what, instead of writing 1 upon B, 1 upon A, 1 upon C everywhere, I will use capital A, capital B, capital C to denote 1 upon A, 1 upon B, 1 upon C. So you are basically asking us what is B plus capital C minus A and C plus A minus B. You know that 2B equal to A plus C, so you can write A as 2B minus C, right? So putting that over there, just get B plus C minus 2B, and this thing is just 2B because A plus C is 2B minus B. So it's going to be B into 2C minus B, so it's 2CB minus B squared, which means this is just incorrect. Then Let's eliminate b in that case. So what was the expression once again? Just b plus c minus a. Okay, and c plus a minus b, and you can say that b is a plus c upon 2, right, which is basically a upon 2, and uh, a upon 2 plus c upon 2. Putting that, you just get 3c upon 2 minus a upon 2, right? Okay, and c upon 2 plus a upon 2. Okay, fine, which is 3c squared upon 4. Okay, minus 1 and plus 3, that is 2. Yeah, that's 2 plus 2 ac upon 4. Okay, and finally for a squared, just minus a squared upon 4, right, this thing, and that's not there. Look at that, it's very different. So this is not correct. Finally we go for excluding c from this. So that's going to be very similar to what we did for a, right? So once again, you can just say like c is what was I going to do, right? So 2b equal to a plus c should be 2b minus a. Putting that in this, you have 3b minus 2a, and then c plus a is just 2b, so 2b minus b is just b. 3b squared minus 2ab. Yes, that's exactly what this thing is. Next, if ABC are in HP, then which of the following is true? ABC in HP, okay. 1 upon b minus a plus, oh god, what is this? No, this is not true. It's not like that. This is incorrect. Is this true? I don't know. The best way to use this substitution was like b is 1 upon capital B and a is 1 upon capital A, and so on. Maybe that will help us somehow. So 1 upon capital B minus 1 upon capital A. That will basically be 1 upon this guy, and this guy. Similarly, that thing will just be BC upon C minus B. So when you combine these, it's just B into C upon C minus B plus A upon A minus B. And you got ABC like this, and then just say this difference is D, or if you want to use capital D, B, and then C minus B will obviously be D. So C upon D, and this will be minus A upon D. But C minus A, that is just 2D, so this will turn out to be 2. This expression is just 2. And this is equal to B? No, how can that be? No, that's not correct. Yeah, that's definitely not correct. This is wrong. Okay, last is, you just got this thing. So B plus A, yeah, that will also turn out to be B plus A, and this will be A minus B, right? Do the math, and believe me, it's how it should be. Similarly, B plus C upon C minus B, I think, yeah, that's equal to 1. Okay, once again, A minus B is just negative D, so this is like 1 upon D into B plus C minus B plus A. This cancels, so just C minus A, which is 2D, but then 2D upon D is 2, so this is also incorrect. So none of these. Wow, did not expect that. Next, 1 plus 3 upon 2 plus 5. Yeah, we know this, we did this for so much of time. So it's A upon 1 minus R, 1 minus 1 upon 2 plus, what is A really? A is just 1 here, plus the difference, which is 2, times R, which is 1 by 2, right? upon 1 minus r squared. Yes, that's correct. This is gone. This is 1 by 2. So it's like 2 and this thing is 1 by 4. So 2 plus 4, 6. Some of these series, once again. Okay, now it's a finite series. Oh no. That isn't supposed to happen. Some of this series is, let's see, 1 plus 2 times 2 plus 3 times. Fine, so just summation of r times 2 to the power of r minus 1, and it's going from r equal to 1 to 100. This is what s is. Okay, just don't write it like this. Last time I did it, it went horribly bad. So just write it like this: s equal to 1 plus 2 into 2 plus 3 into 2 squared all the way till 100 into 2 power 99. Then that means 2 times of s, that's going to be 1 times 2 plus 2 times 2 squared, so on till 99 to the power of 29 times 2 to the power of 99 plus 100 times 2 power 100, and then subtract. So just have s equal to negative 1 plus 2 plus 2 squared all the way till 2 power 99, and then finally plus 100 times 2 power 100. This thing, oh, this is a negative 1 over there. That's not what I want, but at least this thing is doable. So it's 100 times 2 power 100 minus 1 plus, so it's a, which is 2 into r, which is 2 to the power of n 99 minus 1 upon 2 minus 1. 2 minus 1 is 1, and this is 100 times 2 power 100 minus 1 plus 2 power 100, isn't that correct? Okay, minus 2, 101 times 2 power 100 minus 3, and that's just not there. Now what went wrong? What went wrong really? I just subtracted that. Oh, okay, now I understand this. So it's like this thing minus that thing, so all of this should in fact also be negative. So this is negative, 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 everything. This is also in negative, right? So this is incorrect in that case. Okay, then what is this going to be? It's like 100 times 2 power 100 minus this thing 1 plus 2 plus 2 square all the way to 2 power 99. That's 100 terms. So start with 1, right? So it's just 2 power 100 minus 1 upon 2 minus 1, which is 1. That's 99. 2 power 100 plus 1. Cool. Next, sum of the series to n terms is, oh, this is bad. What is this? Fine, I think I know a way to do this thing. So it's 1/3 of 9 plus 99 plus 999 till eventually n of these 9s. So this will be 1/3 of 10 minus 1, right? This thing is 10 minus 1 plus 100 minus 1 plus 1000 minus 1, and so on. Then eventually you got n zeros, so you need 10 power n minus 1. There are exactly n of these because you start with 10 power 1 and end with 10 power n. So it's 1/3 of. So this geometric series, yeah, it's just 10 times 10 power n. Yeah, that's how it should be. And all of this stuff, minus 1, minus 1, minus 1, that's 9. Sorry, that's minus n because n of these. Okay, cool. So it's 1/3 into 10 upon 9 into 10 power n minus 1 minus n, which is 1 upon 27 into 10 to the power of n plus 1, I think, minus 10 minus 3 times n because 1 upon 20 is 1, so 3 times that. Oh well, it's not there. Now what went wrong? Oh, not 3 times that, it's 9 times that, because like that goes there and then yes, this is wrong. So it's minus 9 times n. Okay, this looks correct. Yes, the general term of the sequence is, what's this, 1 2 3 4 2 3 4 5 3 4. Okay, wow, this is weird. Think about it. So you start off with the fourth digit. Yeah, like with the fourth digit you start off with n, I think. The first term n equal to 1, yeah, and then you have n plus 1 as the second digit, and then n plus 2 and so on. So it's like for the first digit you just have 1000 over there, so it's 1000 n plus 100 into n plus 1 plus 10 into n plus 2 plus 1 into n plus 3. And this will be n into 1000 plus 100, which is, okay, this thing once again of 1 and 1, so 1 n, right? And the remaining stuff is like just 100 plus 20 plus 3, so 1 2 3. There we go. This is the general term. Yeah. Okay, next, the integers 2 a b c 160 are such that the first 3 terms in AP while the last 3 terms in GP. Okay, the first 3 terms are in AP while the last 3 terms are in GP. So we can figure out what A and C should be based on B. So it's 2 and 2 plus B upon 2, and then B, and then for C it's just 160B but the square root of that, which will be 4 square root of 10B, I think, and 160. Yes. If the common ratio of the GP and the common ratio of the AP are equal, common difference of the AP are equal, then the value of A plus B plus C is, cool. So what's the common difference? Well, you can write this as 4 upon 2, right? That will just be B minus 2 upon 2. That is the common difference. And what's the common ratio for this thing? Well, it's times what, like, what's the common ratio? It's 160 upon B but the square root of that, so 4 square root of 10 upon B. Cool. Or you could just say that 160 upon B, this is common ratio squared, and this thing squared is common difference squared. Okay, B squared minus 4B plus 4 upon 4 equal to 160 upon B. B cube. This is going to get very ugly. I don't want this to happen. Isn't there a better way? A plus B plus C, you say? Okay, think about it. Come on, think about it. Okay, you just have to solve this, but let's do a good substitution instead. So let's just say that B minus 2 is x, and this will be x squared upon 4 equal to 160 upon x plus 2, like that. So this is going to be x cube plus 2x squared equal to 640. I hate when you have to solve a cubic equation, but you have no other way right now, so might as well just try to guess, basically. So x squared times x plus 2 equal to 640. Maybe you can guess like, okay, 8. Yeah, this makes sense. It's just 8 squared times 10, right? X equal to 8. There we go. You got one solution at least. So let's see if there are other solutions to this. Alright, so x equal to 8 is a solution. X cube plus 2x squared minus 640. and you divide by x minus 8. Let's see if there are other solutions. X squared, x cubed minus 8x squared, subtract this, just get 10x squared. Okay, then you need what, wait a second, yeah, where was I? You just need 10x squared minus 80x, subtract that, so it's going to be 80x because there's no x term. 80x minus 640, yes, and then you just need 80, so this will work. Yes, the other roots are in this equation. X squared plus 10x, what is this thing, plus 80 equal to 0. How can we get this though? Okay, let's just check the discriminant for this thing. B squared is 100 minus 4. Oh yeah, it's negative. There's no other roots other than x equal to 8. So there you go, x equal to 8. That will give us our unique solution. So this thing is basically 64. In other words, b minus 2 upon 2 is 8. So b is 18, I think. There you go, b is 18. You got everything now. So 18 plus 2 is 20. 20 upon 2 is like 10. So 2, 10, 18. And the other thing is c, which is, what was the difference? The difference was 8. The ratio is also 8. So 18 times 8. Wait, what? This doesn't make sense, because it has multiples of 3 in there, and that shouldn't be happening. Okay. B is 18. Oh no. Yeah, like B is 18. That's a problem. Where did we go wrong? Our ratio is 8, right? What else could be the thing? X should be 8. X was 8. Oh, X was 8, not this. Okay, I understand what went wrong. So B is 10. B is 10 instead. So it's 2, 10 and 160. And now A, that will be 6. And this thing, so it's 160, right? So it's going to be 40. Cool, got it. Then A plus B plus C, that's just 56. Next, the sum of 1 cube plus 2 cube plus 3 cube all the way till 15 cube is. So yeah, we just proved this, that 1 cube plus 2 cube all the way till n cubed, that's just n into n plus 1 upon 2 squared. Same thing over here. So it's 15 into 16 upon 2 squared, but 16 upon is like 8. 8 times 15 is 8 and 40, which is 120, I think. Yes, it's 120 squared, which is 14400. Yeah. Next, if this expression is 1/3 of n into n squared minus 1, then Tn is, oh yeah, so this is like for all values of n, I think. First of all, you can write it like this, that 1 squared plus 2 squared all the way to n squared, that's just n into n plus 1 into 2n plus 1. In fact, no, let's just write it as summation of r squared from 1 to n. That's a good form, minus the summation of tr from r equal to 1 to n. That thing is 1/3 n into n squared minus 1, right? So what happens when you change n? So like when you put n minus 1 over there, like n minus 1, and then oh come on, wait, in fact you can write it in a better format. I think you can write it as n minus 1 into n plus 1 upon 3. Yeah, that's, I think, better. So now this will be n minus 2 into n minus 1 into n upon 3. These two are common. That's the whole plan. And now this will be like the previous thing, but from 1 to n minus 1 r squared. Yeah. And then if you subtract these two equations, you just have n squared, because yes, that's just the remaining thing over here that isn't covered in here, minus Tn, and that is equal to So it is this thing minus that thing, which now we know how to do. It's like n into n minus 1 upon 3 into n plus 1, yeah, minus n minus 2, which is 3. This cancels. So Tn is n squared minus n into n minus 1, which is n squared minus of n squared minus n, which is n. Yes, Tn is n. That was weird. Some of the series, just some of the series. So 3 and 7 difference 4, 7 and 11 difference 4, 11 and 15. I knew this would be like that. So just multiply, divide by 4. 1/4 of 1 by 3 minus 1 upon 7 plus 1 by 7 minus 1 upon 11, so on. And it just keeps on going. That means the last is going to be 1 upon infinity, and that is not relevant. So this is gone. Everything is gone except this 1/3. So it's 1 by 12 basically. This series is 1 by 12. If the AM, GM and HM between two positive numbers are equal. Wait, what? All are equal. Well, that means A equal to B. Yeah, without doubt. First of all, for the GM to exist, both must be positive. Next, for the AM to exist, well, I mean, like, yeah, if for the AM to exist, it always exists. For the HM to exist, they should not be 0. None of them should be 0. And these being all equal at the same time, that just means that it must be equal. Both of them must be equal. Only then can this happen. Okay. If A upon B, B upon C, C upon A are in HP, then that basically means like B upon A, C upon B, and C upon A. These are in, wait, did I just mess up something? Yeah, it should be A upon C. Right. These are in AP. Then you want something, right? Multiply this thing by ABC, I think. So B squared C and C squared A and A squared B. These are in AP. Is that somewhere? So B squared C. You don't start with B squared C anywhere. Start with A squared B then. A squared B, A squared B, A squared B. Then C squared A. C squared A. Not there. Not there. Oh no. Oh, this is not in AP. Wait. Oh, this is C squared A. Fine. And then B squared. Yes, this is correct. What about this guy? A squared B. B squared C. C squared. No, that's just wrong. Yeah, fine. Next. If ABC are in GP, then log base A of X, log base B of X, log base C of X are in. Well, you know what? I mean, you can also multiply this thing by ABC and say that that thing is now in HP, but then it would start with A squared C, and that's not there. So this is the only correct option. Okay, next. If ABC are in GP, then this thing, okay, these expressions are in log base A of X. Well, it's in HP. I just know because, yeah, you can write this thing as 1 upon log base X of A, and then ABC are in GP. So these things are in AP, but then the reciprocals of that are in HP. Next, if A1, A2 is to G1, oh, okay, is to not is to, is just semicolon. A1, A2 and G1, G2 and H1, H2 be two AMs, GMs, HMs between the quantities, then this value is equal to, okay, fine. So you know that 1 upon H1 plus 1 upon H2 equal to A1, A2. Oops, sorry. It's equal to 1 upon A plus 1 upon B. And that just means it's like A plus B upon AB. But A plus B is A1 plus A2. And AB is G1, G2. And this thing is just H1 plus H2 upon H1, H2. Cool. What does that mean? What do we want? We want G1, G2 and H1, H2. So G1, G2 upon H1, H2 That thing is a1 plus a2 upon h1 plus h2. Weird, isn't it? Next, if the ratio of harmonic mean, geometric mean of two quantities is 12:13, then the ratio of the numbers is no big deal. So the harmonic mean, that will just be like 2ab upon a plus b, is to the geometric mean, which is square root of ab. And this is what? It's 12:13. That means 12 upon 13. It's like 6 upon 13 because you can get that 2 off. So 6 upon 13 equal to square root of ab upon a plus b. Cool. Square this maybe. Maybe it's not good to square this right away. What do you want? You just want the ratio of these two numbers, right? So let's just say, like, I don't know, b is k times a, and putting that substitution, you can just get this as a square root k upon a times k plus 1, right? This expression, and that would mean like 6 upon 13 is square root of k upon k plus 1. Now let's just say that square root of k is t, so this will be t upon t squared plus 1, and now we are ready to solve. So 6t squared plus 1, okay, no, not 1, 6 equal to 13t. What am I writing? 6t squared minus 13 t plus 6 equal to 0. 6 times 6 is like 36, which we can write as 12 and 3. No, that's not going to work. 13, 4 and 9. Yes, 4 and 9. So 3t minus 2, I think, yeah, that's right, times 2t, right? Because 2t out. Yes, minus 3, yeah, times 3t minus 2 to 0. So like 3t minus 2 into 2t minus 3 equal to 0. So your t is either 2 by 3 or 3 by 2. That means your square root of k is 2/3 or 3 by 2. So k should be 4 by 9 or 9 by 4. Let's see if that is in there. No, the ratio of these two numbers is not this. It's none of these in that case. It should be square root t over there. Okay. Yeah, it's like b upon a, that is k, and you want k, that's 4 upon 9 or 9 upon 4. Take it or leave it. It's not there. Okay. If the AMs of two numbers is greater than GM of the numbers by 2, and the ratio of the numbers is 4:1, and the numbers are, so AM is greater than GM by 2, it's like a plus b upon 2 is GM, which is square root of AB plus 2, and the ratio of the numbers is 4:1. Let's just say like a is, okay, no, let's say b is 4 times a, right? So you just want b's to a, yeah, and that will mean 5a upon 2 equal to 2a. Let's say two positive numbers, yeah, plus 2. That will mean 5a equal to 4a plus 4. So a is equal to 4. There you go. Cool. So a being 4 means b is 16. So it's like 4 and 16. Okay, next, if the ratio of am between two positive real numbers a and b to their hm is m is to n, okay, is m is to n, okay, fine, then a is to b is, oh, this is bad. So the harmonic mean is like just 2ab upon a plus b, and what do you want? Like am is to hm, right? am is just a plus b upon 2. So these two ratios, I mean the ratio of these two numbers, that thing is what? M upon n. Okay, and what does that mean? That means a plus b squared upon 4ab. That thing is m upon n. And you just want the ratio of what? A and b. Let's just say a is k times b, then this will turn out to be k plus 1 squared upon 4k. Yes. Oh, this is going to be bad. Yeah, I'm pretty sure this is going to be bad. Okay, it's like k squared plus 2k plus 1 upon 4k equal to m upon n. Now what do I do? I just want k somehow. Yeah, just like get rid of everything else and bring me k. Let's multiply by -1 on, okay, add -1 on both sides. So this will be k minus 1 squared upon 4k. That thing will be m minus n upon n. Right. What I'm thinking is just take the square root. So k plus 1 upon 4k. Wait, k minus 1. Yeah, like let's say that a was bigger than b. I don't care about that. And that would be square root. Okay, this would be 4 square root. So it is pretty much just 2 square root k over there, right? Taking the square root over there. That's square root of m upon n. And this guy, it's k minus 1 upon, once again, just 2 square root k. And that thing is square root of what? M minus n upon n. So like this thing. And then we can, I don't know, add both of these. Yeah, I think this was correct. Well, looks correct to me. Okay, fine. Add these up. So that will be 2k, that's gone. So k upon square root k is just square root k. There you go. Square root k is square root of m upon n plus square root of m minus n upon n. Right, square this. K is square root of m plus square root of m minus n. This guy squared upon n. There you go. Okay, so hopefully this will give us something nice. Square root of m plus square root of m minus n. That times square root of m plus square root of m minus n upon n. I think this might be like you can rationalize the numerator somehow maybe. So square root of m plus square root of m minus n. Multiply by square root of m minus square root of m minus n. Then this thing will just going to be n upon, yeah, and that n gets cancelled with that. So it's just that thing upon square root of m minus square root of m minus n. There you go. That should be the thing. Yes, this is correct. Next, if x equal to log base 5 of 3 plus log base 7 of, okay, fine. What about it? It's just natural log 3 upon natural log 5 plus natural log 5 upon natural log 7 plus natural log 7 upon natural log 9. I think I know what they want me to do. It's just bigger than or equal to 3 cube root of their multiplication, which is, well, I mean, okay, this cancels. There's only 1.2, I think, because natural log 9 is 2 natural log 3. So, yeah, 3 upon cube root of 3. This guy is bigger than or equal to that. We know it's exactly bigger than that because these numbers are definitely not equal. So using AMGM inequality, we can get this done. And by the way, if you don't know why the AMGM inequality works, you can check out some of my videos. I mean, like, I have proved it in great detail why it works, but like, let's just say if you want a bit of a, I don't know, an easier proof for, like, say 2 numbers, then consider this thing, square root of x minus square root of y squared. That thing is bigger than or equal to 0, right? So square this, it will just not be x plus y minus 2 square root of xy is bigger than or equal to 0. So x plus y upon 2 is bigger than or equal to square root of xy. There you go. This is the AMGM inequality for 2 numbers. Similarly, you can, like, think about this being extended to 3 numbers, but really the proof is, like, much harder for 3 numbers. So maybe go check out my video, that might help. Let's move on. What was the answer though? It's 3 upon cube root of 2, not 3, cube root of 2. Okay, next question. Sum to infinity of the following series shall be. This is stupid. This is like doable. 1 minus 1 upon 2 plus 1 upon 2 minus 1 upon 3, so on. It's 1. Everybody knows how to do this thing. In the geometric progression, the 6th term is 8 times the 3rd term, and sum of the 7th and 8th term is 192. Okay, in a GP, the 6th term is 8 times the third term. That means r cube is 8, r is 2. There you go. And the sum of the seventh term, oh sorry, the sum of the seventh and eighth term, so a7 plus a8 is 192. So that means, what do you want to find though? Sum of the fifth to 11th term. Sixth and ninth, first term and common ratio. You basically want to find everything. So let's just go for the first term. A times r power 6 plus r power 7 equal to 192, right? What is r? R is just 2. So a times 2 to the power of 6 times 2 plus 1, that's 3, equal to 192. So a is 192 upon 2 power 6. Well, is 192 something? Factorize this thing. This guy is 4 times, let's say 16, so 4 and 32, that's going to be 8, which is 2 power 2, then 2 power 2 once again, because yeah, actually 2 power, yeah, this is 16, it's a multiple of 16, so 16 times 3, 16 is 2 power 4, and that times 3, that's going to be 2 power 6 times 3. Cool. Wait, that's exactly this thing. That means a is 1. Then this is wrong. Okay, cool. The common ratio of the GP is 1 upon 2? No. Yeah, it's not 1 upon 2 because the sixth term is 8 times the third term, so it's increasing. Okay, the sum of the fifth, and so what did we just learn? A is 1 and R is 2. That's it, you know the whole GP. Sum of the fifth to 11 terms. Oh, so including both, like a5 all the way till a11. Right, that's just a1 all the way till a11 minus, or you could just do it in the proper way, so like ar power 4 all the way till ar power 10, which is ar power 4 into, well, how many numbers are there though? Right, it's like 4 plus 1 all the way till 4 plus 7, so I think it's 7 numbers. Yes, it's 7 numbers. So r power 7 minus 1 upon r minus 1. R is 2 in this case, that's better. So a times 2 power 4 into 2 power 7 minus 1. 2 minus 1 is just 1, and a is 1. That's nice. There you go. This is the thing. Okay, what about this? This is the sum. Yeah, it's 2032. Really? This is going to be what? 2 power 11. Wait, this is bad. Still, let's just do this thing. 2 power what? 11 minus 2 power 4. We know that 2 power 10 is 1024. Just a quick fact if you want to keep in your mind. So 1024 times 2, that's going to be it's going to be like 2048, right? Yes. Minus 2 power 4 is just 16. So 2 and 3. Yes, this is correct. Sum of the sixth and ninth term is 199. That's like sixth term is just 2 power 5, and ninth term is 2 power 8, I think. Yeah, which is 32 plus, what's this, 8. 2 power 6 is 64. That times like 2, that times 4, which is 24, and 16, 256. 88. It's not 188, so it's incorrect. Next, if the first and something term of AP, GP and HP are equal and their nth term are respectively A, B, C. Oh, so the first terms are equal. N terms are this. Then, okay, so for the AP, wait. Oh, this is weird. Oh, the first and 2n minus 1th terms. Okay, now I understand this thing. So, wait a second. 2n minus 1th term. So, total how many terms are there? Considering 2n minus 1 is the last term. So, yeah, it's just 2n minus 1 terms. What's the midpoint of 2n minus 1 terms? it's an odd number, that means there has to be a midpoint, a median if you say. And that will be minus 1 by 2, that would be, oh come on, yeah, well, am I missing something? Right, so that plus 1, that's 2, and that half of that, that's n. That means the nth term is the midpoint, I think. Yeah, right. So like there's n of these terms, so you got 1 till the nth term, and then from n plus 1 all the way till 2n, there's n more of these terms, and then finally you have 2n. Oh wait, you wanted 2n minus 1. Oh oh no, right, this is not correct. N, and then 1 to n minus 1, there are n minus 1, and n plus 1 to 2n minus 1, there are, it's like n plus n minus 1. So 1 to n minus 1, this is n minus 1, right? So that means, yeah, there's 2n of these terms, but n is the midpoint. Wait, how is this 2n minus 1? Because 2n minus 2 plus 1, so 2n minus 1. Yes, that is correct. Right, so what was I doing? Yeah, just the median. So like the median will be the proper arithmetic and geometric and harmonic means, right? Because for the arithmetic mean, for example, you got some difference. Well, how much of difference is this? It's just, how many jumps did you have to take? n minus 1, right? n minus 1 times d, and from here to here once again you had to take n minus 1d. So this is like 1 and d, sorry, first term, nth term, and 2n minus 1 term, they are in AP. Similarly, for if this was like an HP, then you would take the reciprocals and do the same thing, and those would be in, yeah. So that means, yes, n is both, like all three of them. Yeah, makes sense, perfect sense. Okay, so what was I doing? So AB, and if this was an arithmetic mean, then the nth term would be a plus b upon 2, and some stuff over there. And AB, if this was a harmonic progression, then this would be 2ab upon a plus b. This would be the nth term. Everything else we don't know what that is. Similarly, for the geometric progression, this would be square root of AB, and some stuff which we don't care about. Fine. Right. Oh wait, they already used AB, so let's use capital A, capital B. But you get it, right, what I want to say? Yeah. So once again, you just know, like, harmonic mean squared is arithmetic mean times geometric mean. No, wait, no. The geometric mean squared is the harmonic mean times the arithmetic mean. Yes, that's better. Cool. So that means that this should be, wait, why is this, why is this incorrect? The geometric mean is B, arithmetic and harmonic are A and C. That means B squared equal to AC, right? But they gave this as wrong, which means they want us to choose none of these, right? Cool. If A, B, C are in HP such that A plus B plus C equal to 37, and 1 upon A plus 1 upon B plus 1 upon C is 1 by 4. These mean in HP, that means, yeah, 1 upon A plus 1 upon C is just 2 upon B. So 1 upon B is 1 upon 4 into 3, I think. So B is 12, you already got that. Cool. B is 12, and you have this thing. So once again, doing the thing, yeah, like you can write 1 upon A as, yeah, just make that substitution that A is 1 upon capital A, B is 1 upon capital B, and C is 1 upon capital C. Doing that substitution, just get capital A plus capital B plus capital C over here and stuff, and that just gives us capital B equal to 1 upon 12. That's the first thing. And for this guy, what you're saying is like 1 upon A plus 1 upon B. Yeah, like, okay, you know what, this is bad, this is really bad. This is supposed to be in harmonic means, whatever. 37, there you go. B we already know is just 12, and then this is A plus C, but A plus C is just 2B, so that's 24 upon AC. Hopefully this is correct. Wow, this went so far. The smallest number is okay, why is this 37 of all things? I don't get it. Okay, whatever. 24 upon AC. Oops, 37 minus 1 upon 12. So 1 upon AC, that would be, no, that's not gonna work. This is not gonna work. We need to solve this proper, like, but this is too much. Why is this value 37? Why isn't this something small? Am I missing something? ABC in harmonic progression, these are the reciprocals, there will be an arithmetic progression. So 1 upon A plus 1 upon B. Yes, that is very correct. And you also have that B is 1 upon 12. I get it. Oh, now I understand what went wrong. B is 1 upon 12. Look at that. When you multiply, you just get A plus C upon AC. But A plus C is 2 times of 1 upon 12. That will be 1 upon 6. So 1 upon 12 plus 1 upon 6 AC, that thing is 37. That makes more sense, of course. That, let's multiply this thing by, I don't know, 12. 1 plus 2 upon AC equal to 12 times 30. You still have to multiply this. That's too bad, but gotta do it. So 37 times 12. 6 and 14, that's 74. Yes. 0, 37, 444. Nice number. Yeah. So 2 upon AC equal to 443, I think. Cool. AC is 2 upon 443. Okay, cool. Or you can say like small a, small c. Why? You know what, this is weird, like, yeah, I mean, something is so weird about this. Fine. You know what AC is, you know what A plus C is. Yeah, it's like A plus C is just, what was that once again? A plus C is 1 upon 12. No, it's 2 times 1 upon 12. It's like 1 upon 6. Smallest number is, and putting this back, we just have AC, small AC, that's 443 upon 2. And this thing would just be like A plus C upon AC. So AC upon A plus C, that, or instead, yeah, just write it like this. A plus C upon AC, that thing is 1 upon 6. But that means this is times, that times AC, which is A plus C times, okay, A plus C is 1/6 of that. Yeah. Not a multiple of 3, is it? This is bad. The smallest number is, wow, this is really bad. This doesn't make sense. All you know is that one of these numbers, the mid number, that's like 12. That's it. That's all you know. You don't know anything about the other numbers. But these are in HP. And this is like 1 upon 12. How does this make sense? How can this be 37? of all things. You know that C, if it was like, I don't know, if it's bigger than that, it can at max be like, okay, this doesn't make sense. How can it be an integer? If it was an integer, the maximum that 1 upon C, sorry, that maximum that C can be is 1, and similarly the maximum that A can be is like, I don't know. Yeah, it's horrible. 37 of all things. Why should it be 37? Something's just wrong about this. I can feel this. Okay, next question. X is less than -1. Okay, how much is remaining? Quite a lot. Okay, if x is less than -1 and x mod x plus 1 mod x minus 1 are in AP, then the sum of the first 20 terms of AP is, these are in AP, the sum of first 20 terms of the AP. What? These are in AP, so x is less than -1. That means this guy is like x minus 1 is just negative, right? So you just have x. X being less than -1 means that this is also negative. So this will just be negative x, -1, and negative x, +1. These are in AP. Right, this is like bigger and this is even bigger. Of course, the difference is just 2. So this difference must also be 2. That means 2 is -2x, -1. So -2x is 3. X is -3/2. Cool. This works. It's less than -1. It definitely works. Some of the first 20 terms of the AP, of this AP, I think, right? Where this is the first term, and the difference is of course 2. Right. So 20 upon 2 into 2a minus d. So 2a is -3 minus d, which is 2, times 20 to 2, which is 40. Right? Not times, plus 20 to 2, which is 40. Yes. Cool. If A1, A2, A3, all the way to A10 are in AP, these are in HP, and A1 equal to H1 equal to 2, A10 equal to H1. Right. Then A4 at 7. Oh, come on. A4 at 7. So I think it's time we get a better way to analyze how harmonic progression could be. Right. Think about it. There must be some way to do it. So that's it. There's like exactly 10 of these things, right? Oh, well, maybe you could think of it like this: 9a upon 9, and then you got 9b upon 9. And I know I'm just guessing, but look at that. It's like plus 0a, right? So how many a's you had to reduce? You had to reduce 9 of these a's, and look how many steps you needed. Exactly 9 of these steps. So, and of course in 9 steps we also had this b. So let's say that the difference is b minus a upon 9, which is obviously, it's just that because this thing minus that thing is b minus a. Number of steps is 9. That's the thing. So this is going to be what? 8a plus b upon 9, and then 7a plus 2b upon 9, and so on, right? Yeah. And now for a and b, if this was to be a harmonic progression, we could write this as ab upon b and ab upon a, and we just need to talk about the denominators, right? So let's talk about it like this: 9ab upon 9a and 9ab upon 9. Yeah, that's perfect. So 9ab upon 9b, then the next term will be 9ab upon 8b plus a, and so on, till eventually get 9ab upon 9a. That's our harmonic mean. Cool. And what do you want? You want, so this is the first term, this is the 10th term. So you want h7, so h9 will be 9ab upon 8a plus b, that's 9. For 8 it will be 9ab upon, I just go for 7 directly. So you could go you could like go 3 steps down. So this will be 7a, 9 minus 3 is 7, plus 3b. Like, yeah, that's basically h7, right? Cool. Really cool. Oh wait, sorry, it should be 6 because 9 minus 3 is 6. Yeah, now it's cool. Okay, so h7 you now know that. And what, a4, right? Right. So this is the first thing, so you need to go 3 steps up, and that would mean it's 3b minus 6a upon 9. Now you know what a4 and h7 is. Multiply these out. Oh, it should be positive over there. Yes, same stuff. That is 9ab upon 9. Yeah, which is ab basically. And a and b is 2 and 3, so this is 6 basically. Cool. If if a, x, y, z, b are in HP, and these, okay, fine, 1 upon x plus, so now you know, like 1 upon y is 5 upon 9. Right, so 5 upon 9 is that. But at the same time, you just know, like 1 upon a plus 1 upon b, that's just 2 upon y, which would be 10 upon 9. There you go. This was easy. The sequence a1, a2 all the way to a2n, b's and ap. Oh, so you have a and b over there, and then you have 2n of these terms in between. This sequence is a GP, and this, okay, and the harmonic mean of a and b, oh, it's not his, it is h is the harmonic mean, I think. Okay, cool. It's the harmonic mean of AB. This series is, okay, a1 plus a2n and so on. So you know it's just a plus b. All of these are just a plus b. And similarly, all of these are just ab. How many of these though? So 1 all the way till n. Yeah, n of these. That's what it is. And yeah, this is like 2n and then a plus b upon 2ab. Look at this. This is 1 upon the harmonic mean. It's 2n upon h. Okay. If this thing 1 plus 3 plus 5 all the way to p, well, that means, oh, okay, wait. Fine. And then 1 plus 3 plus 5 all the way till q is 1 plus 3 plus 5 till r, where each set of parentheses contains the sum of consecutive odd integers as shown. The smallest value of p plus q plus r, where p is bigger than 6, is, and you just want the smallest value, right? And like p plus q plus r, so try to keep q and r as small as possible. Well, we know one thing for sure, that the sum of the first n odd numbers is n squared, right? Yeah, this is a very popular thing. So essentially they want to ask us solve a squared plus b squared equal to b squared, equal to c squared, where a, b, c are integers, and find the smallest number such that this can happen. Of course, it's just the Pythagorean triplet 3, 4, 5. That means c is 5, a and b are 3. 3 can be written as 1 plus 2. Wait. Oh, it's like 4 squared. So 3 squared is 9, right? So 1 plus 2 plus, what am I doing? first three odd numbers, it's 1 plus 3 plus 5 plus yep, oh, not 8, it's 9. There we go. Yeah, looks, wait, no, the first, no, wait, the first 4 of them, something's not going correct. First 5 of these would definitely be this thing, so like this cancels. Is this like 9 equal to 1 plus 3 plus 5? Yeah, it is in fact. So this is actually correct. So P should be bigger than 6, then P is equal to 7 will work, Q equal to 5, and R is 9. Smallest possible value of P plus Q plus R, that's like 7 plus 5 plus 9. Right. Which is, what was I going to do? 12 plus 9, which is 21. Sum of all the products of the first n positive integers taken 2 at a time. First n positive integers taken 2 at a time. Yeah, so all of the pairs, right? You know, one way to do this is, just think about it. You got a bunch of numbers, say a plus b plus c, I don't know, like say a1 plus a2 a3 all the way to an. You got all of these, you square this. What's the identity? You have summation of a1 squared plus 2 times the summation of ai aj, where I is not equal to j, and you count ai aj only once, so each of them has a unique, yeah, each of them is unique and you count them only once. So like, I don't know, nc2, that's how many of them will be there. But all we want to find is what this sum is, and we know what it is. It's just summation of a squared minus summation of a squared upon 2. Yay. Right. And now it's the first n positive integers, so this thing is just 1 plus 2 plus 3 till n, so it's going to be n into n plus 1 upon 2 squared minus summation of a squared, that's just n into n plus 1 into 2n plus 1 upon 6, and that thing upon 2. Okay, so it's n into n plus 1 upon 4, yeah, into n plus 1 upon 2 minus 2n plus 1 upon 3, I think. Yeah, that's right. Let's see what this is. 3n squared plus 3n minus 2 goes over there, minus 4n minus 2 upon 6. And this is 3n squared minus n minus 2 upon 6. Can we somehow break this? So n into n plus 1 upon 4, maybe. Okay, 3n squared is like 3n squared minus 3n plus 2n minus 2 upon 6. I think this is going well. This will be written as n minus 1 into 3n plus 2 upon 6. Got it. So it's n minus 1 into n plus 1 into 3n plus 2 upon 24. Oh, it's this thing. If 0 is less than theta, phi is less than pi by 2, and x equal to this sum. Okay, now I'm getting tired of all of this. Just keep going, just 4 questions. Okay, if 0 is less than theta, phi is less than pi by 2, and x is summation from n equal to 0 to infinity of sine 2 power n theta. Right, so theta is just some positive number. Oh, theta comma phi, it's this thing. You should have said it like that. So these two angles, theta phi, are acute, and x is the summation from n equal to 0 to infinity of sine to the power of 2n theta. Okay. And Z is this guy. Then, not a big deal because this is just a GP. So X is essentially 1 upon 1 minus, because like you start from 1. So yeah, and then 1 sin squared of theta, right? Yes, Y is 1 upon 1 minus cosine squared theta, which is basically like this is cosine squared theta, right? 1 upon cosine squared theta. This is 1 upon sine squared theta. Oh, it's sine squared phi. What's Z? What is this? Why is this theta minus phi over there? I don't know. But one thing we know is just cosine theta, cosine. Okay, cosine of theta plus phi, cosine of theta minus phi. That thing is the ratio, right? So it's 1 upon, I mean, you start at 1 anyway. Yeah. Oops. Alright, what about it? Then, so maybe we can write it in a different way. Okay, think about it. You can write this half of 2 cosine of this, right? C of theta plus phi, cosine of theta minus phi, sine of, no wait, it's cosine of that. Yeah, it's got to be cosine of the addition and cosine of the subtraction. That would give this thing. So it's just 2 theta and yeah, and cosine of the subtraction is 2 phi. Oh, you know what? You can write it in a better way. So you can say it's like half of 2 cosine squared theta minus 1 plus 2 cosine squared phi minus 1, which will turn out to be cosine squared theta, cosine squared phi minus 1. And guess what? This is, or you can write this as 1 minus sine squared theta minus sine squared phi. Yeah, both work, whichever you would prefer. And then this 1 minus all of that stuff, that's basically like Z is 1 upon sine squared theta plus sine squared phi, like that. And guess what? Look at this. No, X. Okay, this is cosine squared theta for some reason. Fine. 1 upon X is cosine squared theta. 1 upon Y is cosine sine squared phi. And 1 upon Z is sine squared theta plus sine squared phi, which is basically 1 upon Y plus 1 minus cosine squared phi. Oh, sorry, Y plus 1 minus cosine squared theta. This should be phi. These match up and these don't. So 1 minus sine squared theta. No, what am I saying? I'm thinking something else, saying something else. This sine squared theta, it can be written as 1 minus cosine squared theta, and that cosine squared theta is 1 upon x. So it's like 1 minus 1 upon x. Cool. And now what? So multiplying by xyz, I think. Is that what they did? I don't know. What's this 1 doing over there? This makes no sense. Probably it's this thing that you should be looking at. So multiply this thing by xyz, because there's xyz everywhere. It's probably from multiplying it. So yx equal to xz plus xyz minus zy. Yes, or xyz. Over here you want negative xy. It's negative xy. That thing is zy minus xz. Yes, that's exactly what we want. Okay, value of y equal to 0.64 to the power of log, okay, is, look at this, it's just geometric series. So it's 1/3 upon 2/3, which is 1 by 2. So it's 0.64 to the power of log base 1 upon 4 of what? Of 1 upon 2. it's the square root of that, so this should be just 1 by 2, and this thing would just be 0.8. Cool, done. Okay, next, if ABC are in HB, then this thing is B plus A upon B minus A plus B plus C upon B minus C. ABC in HB, right? Yeah, the same thing. Capital B plus capital A upon this. I've done this question once, I think. If I remember correctly, it will be 2. Still, let's just do this thing. And B plus C upon C minus B. And then A minus B is negative D. So this will be B plus C minus of B plus A. All of that upon B. So C minus A is 2D. So 2D upon D, that's just 2. Exactly. If AM and HM of the roots of the quadratic equation are 3 by 2 and 4 by 3. Oh, cool. Then that equation is, yeah, so alpha plus beta upon 2 is 3 by 2 and what, alpha, 2 alpha beta upon alpha plus beta. That guy is like 4 upon 3, and this thing is just 3 upon 2, we know that. So alpha beta is, reciprocal of 3 upon 2. So this will be 4 by 3 into 3 upon 2, which is 4 upon 2, which is 2. So alpha beta is 2, alpha plus beta upon 2 is 3 by 2, that just means alpha plus beta is 3. So it's x squared minus 3x plus 2, right, equal to 0. So it's x equal to 1 and x equal to 2. Looks correct. Yeah. Okay, cool. Next, the ratio between GMs of the roots of the quadratic equation. Okay, no big deal. Alpha beta, square root of that's just square root of C upon A. Alpha 1 beta 1, square root of alpha 2 beta 2, that's just square root of n upon L. The ratio of these, that would be square root of C upon A, L upon N. So CL upon AN. Cool. Or the reciprocal of that. So AN upon CL. Yes. There's also like B and stuff over there, which we don't really care about. Okay, if G is the geometric mean of x and y, then 1 upon okay, cool. So G squared is just x, y. So 1 upon x into y minus x. Which is 1 upon x minus 1 upon y into 1 upon y minus x. So this is just going to be y minus x upon xy. And that's just 1 upon xy, which is 1 upon g squared. Sum of this series up to 20 terms. Okay, this is bad, really bad. Why do you want me to do this? Up to 20 terms, you say. Okay, what's the general form for this? 1 2 3 4, there's just n. Last term would be n, and what is this? 3 squared and then 5 squared. So it's 2n plus 1 squared, like that. Oh, this is very bad. Yeah, the sum of this thing, that's unexpected. This is very unexpected. So this is basically like n into 4n squared. Yeah, that's not the way to go. Must be some other way to do this, right? Yeah, come on, think about it. How can it be that there's no other way for this to happen? Why is this just all of the odd numbers? Why 2n plus 1? This is painful. All right, we are going to do it. We are going to do it. N into 4n square. I just hate this when they put these kind of questions. I mean, like, who in their sane mind would be doing something like this? Summing this up is just so bad. Yeah, like, whatever. N plus 4n squared plus 4n cubed. Let's go. Sum of n. 20 into 21 upon 2. Okay, which is basically 210. So this thing is 210. Then this guy is 210 squared, which is 441. 400 plus 40 plus 1, which is 441. 100. That times 4. Why? I don't know. 44100. Why this bad number? Okay, n squared. N, which is 20 into n plus 121 upon 2. Well, I mean, that is already there. Whatever. Okay, times 2n plus 1, which is 41, and that thing upon 6, right? So we know all of this is just 210. This is 210 upon 3, basically. So it's like 17 to 41. 17 to 41. It is 0, 7, 28. So it's 2870. And let's see whatever this value is. 0, 0, 4, 6, 1 carried on. 16, so 7. Okay, plus 210. 1 carried on. 9, 7, 1. 179480. Is that somewhere? It's not, as expected. Just hating this right now. Oh, come on. Up to 20 terms. Four n cube plus 4n squared and plus 1. What's the big deal? Oh, 4n squared. I just put n squared over there. This is incorrect. Okay, whatever. 210 times upon 3 times 41, and that times 4. So it's 70 times 41, which was 2870. That times 4. Okay. This times 4, huh? So 210 plus 4 times 0, 7, 9, and then 6 and 4. So 0, 28, 2 carried on, 36 and 2 is 8, 3 carried on, 24, 3, 7, 2, 16 and 2 is 18. One 88090. Please be there. Here it is. Okay, fine. It's done. That was long. So do we have its answers? Oh, there's just so much of this. Okay, there we go. Exercise 1A. Okay, first A, second C, third B, fourth A, fifth C, sixth C, seventh A, eighth A, ninth A, 10D, 11D. Yeah, that's nice. I'm getting correct almost all of them. 13th A, 14th B, 15D, 16th A, 17th B, and then once again B and B, and CDB. Hey, that's nice. And 23 BB. Okay, 24 is B, and 23rd is also B. And 25 ACD. Then BBB. Wait, 30 is B? Yeah, that is in fact B. Right? Just doubt myself too much. Okay, this is B. I mean, yeah, and like 2 years. I have been doing this for 2 years. I shouldn't doubt it that much. 32A, 33C, 34D, okay, DAA, CAD. Okay, cool. Then it should be CCC, 41, CCC, yes. Then BAA. Wait, 46 is D, right? No, it's A. Okay, cool, this is wrong. But this doesn't make sense. A equal to B equal to C. First and 2n minus 1th term of an AP, EGP and HP are equal. Doesn't mean that these must be equal. Right? Whatever. I don't know what this means. Why should it be A equal to B equal to C? Makes no sense. 47. They are saying it's B. I don't know about this. Okay. 48. When is it? 48. C. Cool. And then 49. DAB. 52. BAC. Okay, BAC. Then 55B. 56C. 7th. Then BBB. Yeah, I don't know if this should be correct or not. I think maybe they mean first this quadratic equation on the numerator and this quadratic equation on the denominator. In that case, this might be wrong. But yeah, at least I got the process correctly. Okay, 59th B, 60A. So that's it. I'll see you guys in the next video.